Laws of motion. Yes, in this lecture we will discuss some questions. See, a bomb in the steady state explodes into three parts. Two parts of equal masses move with velocity 30 meters per second in mutually perpendicular directions. The mass of third part is equal to mass of each of these two parts. Find the magnitude and direction of velocity of third part. See what is question. A bomb in steady state. So what is initial condition? See. Initial condition. What is initial condition? Initial condition is one bomb is in steady state. Okay, it is in steady state. It means its initial momentum is 0. Its initial momentum Pi is equal to 0. Clear about this? Okay, yes, as this bomb is in steady state, so it is stationary, so its velocity is 0. So its initial momentum Pi is equal to 0 because momentum is equal to mass into velocity. Okay. Now, a bomb in steady state explodes into three parts. Two parts of equal masses moves with velocity 30 meters per second in mutually perpendicular directions. So now I am assuming, see, here it is. Here it is. Final condition. Okay, let it is origin, x direction, y direction. Clear about this? Okay, yes, it is minus y axis, it is minus x axis. Initially, let this bomb is here at origin. Now, a bomb in the steady state explodes into three parts. Two parts of equal masses moves with velocity 30 meters per second in mutually perpendicular direction. Two parts of equal masses moves with velocity 30 meters per second in mutually perpendicular directions. Then see how, if it is bomb, then I am assuming the first part, it is moving in this direction. Second part, that it is moving in this direction. Yes, it is moving in this direction. So its velocity here it is v1. It is moving in this direction. So yes, its velocity here it is v2. Clear about this? Of equal masses. So let's mass of this first particle is m. Mass of this second particle is also m. Now read this data. See, two parts of equal masses m and n moves with velocity 30 meters per second in mutually perpendicular direction. One is moving in x direction and one is moving in y direction. So yes, mutually perpendicular directions. Clear about this? Now how to write this velocity? See, this first particle is moving with 30 meters per second in x direction. Then how to write v1? Yes, I can write v1 is equal to 30 I caret. Clear about this? I have assumed this first particle is moving in x direction with 30 meters per second. So I can write 30 I caret. V2, how to write V2? V2 is equal to, it is moving with 30 meters per second in y direction. So I can write it is 30 j caret. I can write it is 30 j caret. Clear about this? Clear about this? Okay. So yes, two parts of equal masses moves with velocity 30 meters per second in mutually perpendicular directions. The mass of third particle is equal to mass of each of these two particles. See, mass of third particle, mass of third particle, m3 is equal to it is 3m. Yes. First two particles, they having same mass. So I can write m1 is equal to m2 is equal to m. But what about m3 is equal to 3m. Clear about this? Okay? Okay. Find the magnitude and direction of velocity of third part. Okay, you have to find v3. v3 is equal to what? v3 is is equal to what? Okay, in which direction? If bomb explodes in three parts, first part, second part, then third part is moving with which speed and in which direction? Okay. Now see, in initial condition, we have a stationary bomb, so initial momentum is 0. In final condition, this bomb explodes in three parts, first part, second part, and third part. Let that third part begins in this direction. Okay. Suppose I have assumed that third part it is moving in this direction, having mass 3m, and it is moving with velocity v3. It is moving with velocity v3. Then see, in final condition we have three parts. We have three parts. So what is final momentum? What is final momentum? Final momentum Pf is equal to P1 plus P2 plus P3. Okay, yes, initially we have a stationary bomb, but finally after explosion we have three parts, first, second and third part. So what is total final momentum? Momentum of first particle, momentum of second particle, and momentum of third particle. Clear about this? Clear about this? Okay, so yes, it is final momentum. Now, no external force. Bomb explodes due to chemical forces inside. Okay, so yes, according to law of conservation of momentum, 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 initial momentum is equal to final momentum. Initial momentum is 0. Final momentum is, yes, it is P1 plus P2 plus P. Clear about this? Okay. 0 is equal to P1 means m1 v1 mass into velocity, m2 v2 mass into velocity, plus m3 v3. Okay. So therefore 0 is equal to. So therefore 0 is equal to, now we have to put values of m1, m2 and m3. Now we have to put values of m1, m2 and m3. See how? What is value of m1? Mass of first particle. Yes, it is m. v1, it is 30 I caret. 30 I caret. Okay. Plus m2, it is m. v2, yes, it is 30 j caret. Clear about this? What about m3, mass of third particle? 3 times. Okay. So yes, it is 3m, and v3 we have to find, and v3 we have to find. Clear about this? Okay. Now, how to simplify this? How to simplify this? See, here it is 3m, 3 into m, 3 into m, common? Yes or no? Then I can write this equation as 0 is equal to 3m common. Here in bracket we will have m common, 3 common, then yes, it is 10 I caret. Clear? Plus again here it is 10 j caret. 3m common, then yes, here we have only v3. Clear? Okay. Now this 3m, if it moves in this direction, it will become 0. So what we will have? What we will have? See, we will have 10i. We will have 10i plus 10j plus 10j plus v3 is equal to 0. Is equal to 0. So now make v3 as subject. Then v3 is equal to minus 10i minus 10j. Clear? So yes, it is v3, velocity vector. Now we have to find its magnitude and direction. Now we have to find its magnitude and direction. How to find magnitude? See, v3, its magnitude. Yes, you know how to find magnitude. Minus 10 square plus minus 10 square is equal to, it is 100 plus 100. So yes, it is under root 2 times 100. So yes, it is 10 root 2 meter per second. What is speed of first particle? 30 meter per second. What is speed of second particle? 30 meter per second. What is speed of third particle? 10 root 2 meter per second. What is direction of first two particles? First in x direction, second in y direction. So what is direction of third particle? See, here it is direction of third particle. Direction of third part. Direction of third part. Theta is equal to tan inverse. Y component minus 10. X component minus 10. Minus 10 upon minus 10. So yes, it is tan inverse 1. And you know, okay, for angle theta is equal to 45 degree, value of tan is 1. So yes, it is 45 degree. But 45 degree with, see here it is. V3 is equal to minus 10i minus 10j. X component is negative, Y component is negative, both components are negative, means velocity is in third quadrant. In third quadrant, see this figure, first quadrant, second, third and fourth. So yes, in third quadrant, it makes angle with negative x-axis. It makes angle with negative x-axis. So this 45 degree is with negative x-axis. With negative x-axis. So yes, it is your answer. Third particle will move with speed 10 to 2 meter per second in direction 45 degree with negative x-axis. With negative x-axis. Clear about this? So yes, you have to take care about figure. Okay, how to draw figure, how to write V1, V2 and how to find V3. It is one question based on law of conservation of momentum. Okay, write down from board. Now we will see another question, exercise 5.7. See, a body of mass 5 kg. So yes, M is equal to 5 kg. Is acted upon by two perpendicular forces, 8 Newton and 6 Newton. For example, it is body. Okay, let it is acted upon by two forces. Here it is F1 is equal to 8 Newton and here it is F2 is equal to 6 Newton. Okay, its mass is M. Okay, give the magnitude and direction of acceleration of the force. See, two forces are acting, but yes, these two forces are not acting in same direction. See, yes, you are given mass and you have to find acceleration. Yes, you know equation. Which equation you have to use? Acceleration is equal to force upon mass. But what about force? What about force? Yes, you have to find resultant of these two forces. Force is vector quantity. Force is vector quantity. So yes, you cannot add them directly. You have to first of all observe their direction. Here F1, 8 Newton in this direction. F2, 6 Newton in this direction. Yes, they both are perpendicular. They both are perpendicular. So first of all, you have to find the resultant. See, first of all, find resultant force. First of all, find resultant force. Resultant force F is equal to, yes, here it is under root F1 square plus F2 square. Yes, F1 square plus F2 square. How directly? How directly? Yes, you can use law of parallelogram. What is angle between them? 90 and cos 90 will become 0. If I want to write 2F1 F2 cos 90. Clear about this? Cos 90 will become 0. Then yes, F is equal to under root F1 square means 8 square, F2 square means 6 square, 8 square it is 64, 6 square it is 36, and yes, total is under root 100, then force is 10 Newton. Then force is 10 Newton. Clear about this? So yes, that resultant force F is equal to, here it is 10 Newton. Force F is equal to, here it is 10 Newton. Clear about this? Clear about this? Okay, so yes, force is 10 Newton. Then how to find acceleration? Acceleration is equal to, it is force upon mass. Force is 10 and what is mass? Yes, here it is 5 kg. So acceleration is 2 meter per second square. Acceleration is 2 meter per second square. And yes, it is in the direction of resultant force. Resultant force is in this direction. It is in direction of resultant force. Clear about this? Yes, it is direction of resultant force. How to draw the direction of resultant force? according to law of parallelogram. It is F is equal to, here it is 10. Now how to find direction? See, let it is angle theta. Let it is angle theta. Let it is angle theta. Okay. If I apply tan theta means opposite side upon adjacent side. Okay. Then how to find direction? So yes, theta is equal to, it is tan inverse. Opposite side means it is 6 divided by, here it is 3. So yes, theta is equal to, here it is tan inverse 3 by tan inverse 3 by. Clear about this? So yes, a body of mass 5 kg acted upon by two perpendicular forces 8 Newton and 6 Newton give the magnitude and direction of acceleration of force. How to find resultant force, magnitude and direction. Clear about this? So yes, it is one question in which you have to find what is resultant force. Okay, now next question. See, a batsman deflects a ball by an angle of 45 degrees without changing its initial speed, which is equal to 54 km per hour. What is impulse imparted to ball? Mass of ball is 0.15 kg. See, what is Q1? What you have to find? Okay. Yes, first of all, understand question. Okay, how to solve this question? A batsman deflects the ball by an angle of 45 degrees without changing its speed. It means, see, suppose it is ball. Suppose it is ball. It is moving with speed u. With speed u. Batsman hits the ball. Suppose it is bat. Suppose it is bat. Batsman hits the ball by an angle of 45 degrees without changing its initial speed. At angle 45 degree. At angle 45 degree. At angle 45 degree without changing its initial speed. Its initial speed it is u and final speed it is also u, which is equal to 54 km per hour. Yes, u is equal to, you are given 54 km per hour. You have to convert in meter per second. What is impulse imparted to ball? Yes, we know impulse is equal to change in momentum, is equal to change in momentum, is equal to delta P, is equal to final momentum minus initial momentum, is equal to mv2 minus mv1, is equal to mv2 minus v1. So yes, we will find initial velocity and final velocity. See, here it is. I am assuming this direction x and this direction y. Okay, yes, initially ball is moving in this direction. Then how to write initial velocity? v1 is equal to u I caret. Any doubt? Yes, initially it is moving in this direction, direction of x. So I can write u I caret. Now finally, after it is moving in this direction, so yes, you have to resolve this into components. You have to resolve this into components. How to take components? See, as it is moving in this direction, its two components are first component in this direction and second component in this direction. Clear? Now it is 45 degree. So yes, with this component it will become cos. So it is u cos 45 and it will become u sin 45. Clear about this? Okay, yes, after striking with back it is moving in this direction, so it's two components, clear about this? Okay, see, this component is in negative x direction, this component is in negative x direction, then how to write? Minus u cos 45 I caret. This component is in positive y direction, then how to write? Plus u sin 45 j caret. Clear about this? Clear about this? Okay, then yes, I can simplify this as minus u cos 45 means 1 upon root 2 I caret. Sin 45 means 1 upon root 2 j caret. Clear about this? So yes, these values of v1 and v2. Okay, now put value in this equation. So therefore impulse is equal to, yes, m What is final velocity v2? Minus u upon root 2I plus u upon root 2j. Okay, what is initial speed? v1, it is minus u1. It is minus u1. Clear about this? Clear about this? Okay, so yes, u common, then yes, it is n u common. Here, what we will do? I carry, there are two terms having I carry. There are two terms having I carry. Yes, it is 1 upon, sorry, minus 1 upon root 2 minus 1 I carry plus 1 upon root 2 j carry plus 1 upon root 2 j carry. Clear about this? Okay, now what you have to do, you have to find its magnitude. Okay, put value of m 0.15, put value of u by converting this, okay, and find magnitude of this, and find magnitude of this. You will get your answer. Yes, you have to try to solve this. You have to try to solve this. If you have any doubt, then yes, please contact me. But yes, this term, yes, we have discussed in chapter number 4. So yes, you have to try to solve this. Simplify 1 upon root 2 minus 1 with the help of calculator. You will get some answer. Again, 1 upon root 2 with the help of calculator. Then you can easily find. Clear about this? Okay. So yes, it is one question in which you have to find what is impulse. Impulse means again changing momentum. Delta P, P2 minus P1, mv2 minus mv1, mv2 minus v1. Yes, see, this equation we have used 3 or 4 times. So now remember this equation directly. Find initial velocity and then find impulse. Clear about this? Yes. Watch videos regularly, make notes, solve your doubts, and yes, appear in exam. Okay, and yes, do not forget to like, comment, and share our videos. Thank you.